Let's do this exercise together. Because the student grade class has this class variable, we need to define the standard grade first. And the value of this standard grade is 159. And this is shared across all instances of student grade. And of course, we need to define the constructor or initiator. And we need to be careful about passing this self instance. And then we pass student name and grade. Okay. And we're going to just assign this student name to this student name. And grade to grade. That's the initiator. And the we need to implement this need to study more. And although it does not receive any arguments, the default argument is the instance itself, which is represented by self. And it's going to return whether the current grade is smaller than the self.standard grade, like this. So this is the implementation. You can implement this in this way, like if this one is satisfied, return true, else return false, like this. So both implementations are okay. All right. Thank you for sharing your answers. Let's move on. So up to this point, we talked about how we define a class, and we talked about class variables. And we're going to talk about public and private attributes of classes. Let's say we want to implement a product class, and we are managing some products for a shop, and we need to define the initiator or the constructor. And let's say that the product name is Galaxy 23. And let's say the price is 150. However, sometimes we offer some special price to different customers, right? Let's say the real price is 50. However, we do not want to disclose this information to customers. Let's see what happens when we want to print info method like this. Self.real price. This one is product instance. And when we try to print P1 semi price, it returns it's 150. However, when we want to print out this real price, it's going to incur an error. It says this product object does not have attribute double underbar real price. Okay. However, when we call p1.print info, let's see what happens. This prints out this value correctly. So what is the difference? If you put two underbars in front of a variable, then this variable can be accessed through this instance. However, outside of this instance, you cannot access to this variable. Okay, so this is to protect some instance variables from outsiders. So let's say you are implementing this part. However, you do not want to share this code to users. However, users might want to know all the variables inside this product class, and they're going to do this dot operation, and it shows print info instance and name instance. However, this semi price or double underbar real price do not show up here. Okay, so it is called semi or semi-private attribute. And this one is private attribute. Okay, this is just to hide this information from users. That's all. Okay. All right, this was public and private attributes. And let's talk about inheritance. So in the class slides, I told you that there are three things we want to do. The first thing was encapsulation. We want to hide some implementation information from users. So there are some abstraction barriers. So let's say we are using this print function. However, we do not care about the implementation of this print function, right? So we can do the same thing for our users. We can hide how these are implemented or what kind of variables our function or class have. The users just use our implementation. That's all. So this is to ensure encapsulation. Users do not need to care about the implementation. Okay, so that is the first thing we discussed. And from now on, we are going to talk about inheritance. So what is inheritance? Let's say we want to implement some objects for zoo. So we have rabbit, panda, elephant, vulture, and lion. However, animals have some shared behaviors, like they all eat and they all move. However, elephant need to crawl or need to stay on the ground. However, vulture can fly over the sky. So this move functionality might be somewhat different. However, they all move, right? And rather than implementing eat method for panda and rabbit separately, we can make a template and then somewhat change a little bit and apply this eat method to panda. That's what we are going to do. So inheritance is going to be all our animals, and they're going to share some functionalities. So by doing so, we can reuse our implementation. So let's see what this means. So first, we are going to implement animal class. And this animal class, of course, have initiator like this, and the age is like 0. And let's say all animals have the functionality of play. They can play for a couple of hours. Let's pass this implementation. And all animals, as I told you, can eat, right? And all animals can move, right? And what we want to do is defining rabbit based on this animal class. And that is called inheritance. And what is the advantage of inheritance? Even though you do not implement anything for this rabbit, it already has the functionality of this eat or play or move. You can use all functionalities of parent animal class. So here we say animal is parent class or superclass. On the other hand, we call this rabbit as child or children class or subclass. Okay, that's the terminology. And let's see what we can do. Let's say the functionality of eat method of parent class animal, parent eat, printing parent eat. And in the case of rabbit eat, it's going to be rabbit eat. And let's say move. Prints out parent move. And let's make an animal. Like this, and rabbit. Like this. And when we run this part, even though we do not implement the constructor for this class, rabbit, it borrows this constructor from its parent class and uses this instructor for this rabbit class, right? So even though we call this part, it automatically binds to this constructor and it calls this constructor from parent class. And when we call this eat method, because this rabbit class has this eat method, it prints out rabbit eat like this. However, when we call this eat for animal, it prints this eat method. And when we call this move method, it prints out parent move. Okay, so if this parent animal has some functionalities for this rabbit class, then this rabbit class can borrow the methods from its parent. All right, so that's the beauty of inheritance. All right, I'll give you another PPT exercise. So is there any question regarding inheritance? So basically you put the parent class name inside these, between these two parentheses. That's all you need to do. So I'll give you one PPP exercise to practice inheritance. This was our clothing class we implemented, and try to implement these key clothing that inherits from clothing class, okay?